Hello friends and good afternoon. Welcome to our channel of structural analysis. I am very happy to share with you that the channel has now got subscribers of 202 and still the number is going on increasing. Thank you very much for the positive response that is got from the students. So today we shall start with one more new problem on stiffness matrix method. One more two span continuous beam. So let us start with the analysis of this beam by stiffness matrix method. So this is one beam wherein first span, let us say AB, is a 5 meter span subjected to a UDL of 10 kilonewton per meter. Second span is 6 meter span and it is subjected to a 12 kilonewton central point load. So let us start with the analysis. Our step number 1 will be finding out kinematic indeterminacy of the beam. So Ki value for this particular beam is 2. Those two unknowns, displacement quantities, we shall assume as theta b and theta c. Okay. So these are two unknowns that we have to identify. We shall give numbering to these two unknowns. So let delta 1 is equal to theta b and delta 2 is equal to theta c. So now step number 2 will be fixed end moments. So fixed end moments will be, one will be for span AB. So MF AB is equal to minus WL square by 12. So minus 10 into 5 square upon 12. So let us calculate the value. Ten into 5 square upon 12. So it is minus 20.83 kilonewton meter. Then MFBA is plus 10 into 5 square upon 12. So value is plus 20.83 kilonewton meter. Then second span is MFBC. So it is minus WL by 8. So minus 12 into 6 upon 8. So answer is minus 9 kilonewton meter. And MFCB is plus 12 into 6 by 8. So it is plus 9 kilonewton meter. Then step number 3 will be finding out fixed end moments. So why to find fixed end moments? Because our two unknowns are rotations. So at these two locations B and C, we will find summation of fixed end moments. So step number 3 will be summation of fixed end moments. So first summation we are going to designate it as PL1. So PL1 is sum of fixed end moments at joint B. So MFBA plus MFBC. So what is BA? 20.83. What is BC? Minus 9. So take the algebraic addition of these two values. So minus 9. So it will be 11.83. 11.83 kilonewton meter. Then PL2 is MF CB because second location is C. So on joint C we have only one fixed end moment, 9 kilonewton meter. P1, P2 both are 0. Why? No external couple. No external couple. Now, next will be finding out the stiffness matrix elements one by one. So for that, we need to remove the external loading. Take our first unknown, make its value 1, second unknown, make it 0. So, our first unknown will be theta b, we will apply unit value. We will apply its unit value. So, apply unit rotation at 1. So, after applying unit rotation at 1, we will also draw the deformed shape of the beam. So let us first of all draw this beam. Please remember we are making our second unknown 0. It means rotation of this joint we are stopping or making it 0. So we are applying rotation on joint B. So after applying unit rotation on joint B in clockwise direction, the deformed shape of the beam will be something like this. Yes. So this is unit rotation applied, 1 radian. So this is a joint which is undergoing rotation and far end becomes fixed. So this case becomes individually a propped cantilever beam subjected to clockwise movement. So here stiffness induced is 4EI upon L1. Here it is 4EI by L2 and its half values will be on far end. 2EI by L1 here, 2EI by L2 here. So this is 2 and this is 1. So we will have to find now what are the reactions induced because of the action applied on 1. So what is reaction induced on 1? These two values together. So this will be K11. What is K11? Moment at 1 due to unit rotation of 1. So value is 4EI by L1 which is from span AB plus 4EI by L2 which is from span BC. So what is the value? 4EI by 5 plus 4EI by 6. I value for both the spans is 1. So 4EI by 5 plus 4EI by 6. So 1.47 EI. Now K21. So look in the diagram at location 2. What is the value? 2EI by L2. It is for span BC. So it is 2EI by 6. So 2 by 6 is 1 by 3. So it is 0.33 EI. Now step number 5. We will go to now our second unknown, we will make its value 1 and first value we will make 0. So our step number 5 will be apply unit rotation at 2. Okay, so we will again draw the deformed shape of the beam by applying unit rotation and 2 on 2. And we are making location 1, rotation 0. So what will be deformed shape here? Let us draw. Something like this will be there. This is 1 radian rotation. So value here is 4 EI upon L2. Here 2 EI by L2. So this is our location 1. This is number 2. So again we will note down what are the reactions induced on both the locations because of unit rotation applied on 2. Okay, so let us write. So we will go to first of all location 1. So K1 2. What is K1 2? Moment at 1 due to unit rotation of 2. Okay. So what is the value? 2 EI by L2. It is again for span BC. So 2 EI by 6. So it is again 0.33 EI, which is matching with K21. Okay. Then K22. What is K22? Moment at 2 due to unit rotation of 2. So let us write this value. So look at location number 2. So at location number 2, we have value 4 EI by L2, which is again for span BC. So 4 EI by 6. 4 EI by 6 is 2 by 3. Correct? So 2 by 3 is 0.67 EI. Yes. So all these values we have got. I'll just note down this PL1 value here, 11.83. It is PL1. Now we will go for the solution of our 2 by 2 matrix. Okay. So step number 6. Now we will put all these values in the matrix. So on left hand side we have our unknowns delta 1 and delta 2. It is equal to inverse of our 2 by 2 matrix. So first value is K11 1.47 EI. Second value K12 0.33 EI. Then K21 again 0.33 EI and K22 is 0.67 EI. So these are stiffness matrix elements. We have entered them. Then P1, P2 values. What are P1, P2? Both are 0. Then PL values. First value is 11.83. Second value is 9. So now we shall solve this 2 by 2 matrix. Solving a 2 by 2 matrix is simple. So how to do it? Let us see. Okay. So this is delta 1 and delta 2. First of all, we will get the determinant of the 2 by 2 matrix. Okay. So determinant is multiplication of diagonal elements. So 1.47 into 0.67 minus 0.33 square over. So this is 0.876. So this is determinant of the 2 by 2 matrix. Now small change in the position of elements of the matrix, interchange of the diagonal elements. So this is 0.67 and this is 1.47 here. The remaining two diagonal elements will be same but with opposite sign. Plus 0.33 is here, make it here minus. Then next matrix 0 minus 11.83. So this is minus 11.83 and 0 minus 9 is minus 9 over. Inverse of the matrix is over. Now we will find the unknowns using multiplication and division of matrices. So delta 1, what will be delta 1? Row into column. 0.67 into minus 11.83, then minus 0.33 into minus 9, totally divided by 0.876 EI. Okay, so let us find this first unknown. 0.67 into minus 11.83 minus 0.33 into 9, totally divided by 0.876. So this is minus 5.66 upon EI. So this is our first unknown, theta b. Then delta 2 is minus 0.33 into minus 11.83 plus 1.47 into minus 9. Again this is totally divided by 0.876 EI. So answer is minus 10.65 upon EI. So this is theta c. Now we will go for final moments. Final moments. So these are final moments. These moments have been calculated using slope deflection equations. Those who do not know how to calculate these equations, please refer my videos on slope deflection method, wherein I have solved beams using slope deflection method. So these are final moments. Now I will just note these values here in the loading diagram. So minus 23.08, it means anti-clockwise. Then this value is 16.33, here clockwise, here anti-clockwise, and 0 on support C. Okay, so now we have to find reactions. Reactions we will need because we have to draw SFD and BMD. So how to find reactions? Simple. First of all, take free body diagram of span AB. B span is an interior span, so make it fixed. Here show final moment values. So this is 23.08, this is 16.33, this is A, this is B. External load is UDL. So the value of this external load is 10 kilonewton per meter. This is reaction at RA. This is RB1, we shall say. 6 meter, no, 5 meter is the span. So summation of moment about support A, it is equal to 0. So write the equation minus RB1 into 6 plus 16.33 plus 10 into 5 square by 2 and minus 23.08. This is equal to 0. So what will be RB1? Let us calculate. So 16.33 plus 10 into 5 square by 2 minus 23.08 upon 6. So answer is 19.71. RB1 value is 19.71 kilonewton. Summation Fy is equal to 0, it's second condition. So we will get RA as 10 into 5 minus 19.71. So let us see how much is this value. 50 minus 19.71. So it is 30.29. 30.29 kilonewton. Both reactions are upward. Now we will go for free body diagram of span BC. So here free body diagram of span BC. Here again we will get two reactions. One is on B, another is on C. So this reaction we shall assume RB2. This is RC. So here is the final moment, 16.33 anti-clockwise. Now apply summation of moment on B. So minus RC into 6 plus 12 into 3 minus 16.33, it is equal to 0. So find out RC value from this. So 12 into 3 is 36 minus 16.33 upon 6. So 3.28 kilonewton. Again, second condition is summation Fy is equal to 0. So RB2, it is equal to 12 minus 3.28. So it is 8.72 kilonewton. So what will be net RB? RB1 plus RB2. What is RB1? 19.71 plus RB2 is 8.72. Let us find this value. So it is 28.43 kilonewton. Okay, so let us show first of all these reactions now. So RA is 30.29, net RB value 28.43, and RC is 3.28. Now we shall draw shear force diagram. So here 30.29 is the shear force, 30.29. Then 30.29 minus 10 into 5. So it is minus 19.71. So here somewhere approximately 19.71 minus 19.71 plus 28.43. So it is 8.72. It will be same up to 12 kilonewton point load. So 8.72 minus 12. So it is minus 3.28. So bring it down. Minus 3.28. It will be same up to joint C, then 0. So this is our shear force diagram. So we have got points of locations of 0 shear force. However, this distance is unknown. So let us first of all find this distance. So this is x from here to here, and this is pi minus x. Okay, so using similarity of triangles, we will get these two distances. So let us find. For x we have 30.29 value. For pi minus x we have 19.71 value. So let us do it. So it is 151.45 minus 30.29x. It is equal to 19.71x. So x is, let us find, 151.45 divided by 30.29 plus 19.71. So it is 3.03 meters. X is 3.03 meters. So we will take a section here in the loading diagram. We will consider left hand side part of the section, and we will write equation for bending moment at x is equal to 3.03 meter. Okay. So let us write 30.29 into 3.03 minus 23.08 minus 10 into 3.03 square by 2. Let us see the answer. $22.79. kilonewton meter. So here we have got 22.79 kilonewton meter value. We have to get here also now. So we will take this section, right hand side of this section. So value at bending moment at x is equal to 3. So we shall say this is D, or this is D, and this is E. So bending moment at E, it is 3.28 into 3. I am taking this clockwise because as per the sign conventions, I am treating anti-clockwise moment on right hand side of the section positive. So 3.28 into 3. Answer is 9.84. 9.84 kilonewton meter. So let us now draw bending moment diagram on tension side. Okay. So first value is minus 23.08. So it will be somewhere here below the reference line. 23.08. Next is here under D, value is 22.79 plus value 22.79 kilonewton meter. Here 16.33. Here 9.84. Now let us join all these ordinates 1, 2, 3, 4 and 5. Here is 0. So for A to B, variation is parabolic. Then it is linear. Over. Our BMD on tension side is over. This is minus, this is plus, minus, plus. So this is BMD and this is SFD. Over. So guys, if you have not understood any of the steps, do write in the comment section. If you like the video, please press right button on the channel. Thank you very much.